So here is another example, which is in your packet, of a parabola, where this parabola starts out with negative x squared. So right away, we're going to know that it's going to open down, but we will discuss that again a little bit towards the end. Since the a value is less than 0, meaning negative, it will open down. The first step we did was to find the axis of symmetry, which comes from the equation x equals negative b over 2a. For this problem, a equals the coefficient of x squared, which is negative 1, and b is 8. So we're going to substitute those values into the formula. On this problem, because b is just 8, when we fill it in here, negative b will just be negative 8. We don't have the double negative going on here. So we have negative 8 on top over negative 2 on the bottom, which will equal 4. We can now start our XY chart. So here we have our XY chart, and I'm placing our axis value of 4 in the middle, and now we're going to find the Y value, which is step 2. So our X value is 4. We have negative X squared. When we fill that in, the negative stays on the outside and just the 4 goes on the inside. When we evaluate this here, because of the negative on the outside, it's going to stay negative 16. And then here's the plus 8 times 4 minus 12. So here we have negative 16 plus 32 minus 12, which will work out to be 4. So this is the Y value of 4 that goes with our X value of 4. We're going to put it in our chart. You have just found the vertex, and you will realize this more when you do the graphing. Step 3 is where we find our x-intercepts. And recall that x-intercepts are found where the graph crosses exactly on the x-axis, so the y value will be 0. So we're going to take the y, make it be 0, and set the equation equal to 0, factor, and get our x-intercepts. So here we have 0 for the y value equals the trinomial. Now we want to solve this equation. This trinomial starts with a negative x squared. It's much easier to factor when this is a positive x squared. There are 3 different ways we can do this. We could take all 3 of these terms and move them to the left, which will make this be a positive x squared, a negative 8x, and a positive 12. Or we could factor out a GCF of negative 1. The new way I'm going to show you is because you have an equation, we essentially can multiply through by negative 1, which will change all the signs for us. So we're going to show that by putting the entire problem in parentheses and multiplying by a negative 1. So here, we're going to multiply through by negative 1, which will keep this a 0, but it will change all of these signs on the right. So now we have a trinomial that starts out with positive x squared. It'll be easier to factor. So this is an easy trinomial. We're going to start with our 2 parentheses here and here, and put x and x in the front of each. And factors of 12 that will add to negative 8 will have to be negative 6 times negative 2. So setting each of these factors equal to 0 will give us x equals 6 and x equals 2. So we have our 6 and 2. We're going to now place these numbers in our chart, and it always is nice to put them in the correct order. It shows balance with your points. So there we place the 2 and 6, and we automatically know the y value is 0 because we set this equation equal to 0 for y. So this step 3 is the one that is a little bit trickier when our problem starts out with a negative x squared because of multiplying through by a negative before you do the factoring step. So now we're going to look, if you're following your steps from the notes, step 4 we're going to skip because we do have x-intercepts. We don't need to find any additional points in our chart. Step 5 is where we find our y-intercept. Remember, a y-intercept has to be a point on the y-axis here. The x-coordinate will be 0. So this is where we're putting 0 in for x. So we're going to put 0 in our chart for the x side. So here we put 0, and the x side we'll find the y value, and this will give us our y-intercept. Y-intercept really is a quick one to find. If we come up to our equation, we're putting 0 in for x, so this will be 0, 8 times 0 will be 0, and we'll get negative 12. You do have to remember at this step, when you're substituting x equals 0 in, to go all the way up to your original equation, not the one here where we changed the signs. So we have our y value of negative 12. We're going to put it in our chart over here. So we're ready to start plotting the points that we have. I'm going to start with 0, negative 12. So go left or right, nothing, and go down to negative 12. That will end up being just one line above the bottom of this graph. It's a little hard to see, but I did put a point right here. That's our y-intercept. So now we're going to plot 2, 0 and 4, 4. So here I've plotted 2, 0 and over 4 up 4. Our next point to plot is 6, 0. So there's 6, 0. The next thing we're going to do is sketch in the axis of symmetry, which in this problem was at 4. Right here is our axis, which is the middle of our parabola. I'm going to sketch a dotted line in there. So here's our axis of symmetry. What I didn't show too clearly on the example previous to this was finding the reflection point for the y-intercept. So here's our y-intercept, and we're going to count 1, 2, 3, 4. It's 4 units away from our axis of symmetry. So our reflection point is 4 units to the right. 1, 2, 3, 4. So we're going to plot that balance point right there to create our symmetry. So here's our reflection point for this y-intercept, 4 units away. 1, 2, 3, 4. Now we're ready to connect our downward opening parabola, where this is your high point or your vertex. So there's our sketch. And again, I apologize for the inaccuracy. The sketching tool I'm using is difficult to make a nice curve with. Now we just need to answer the questions about the axis, vertex, intercepts, and the opening up or down. I like to start with our axis of symmetry. Remember to use the x when you write the equation for the axis of symmetry. And the next point we're going to list is our vertex, which is our high point on the graph, which in this problem was 4, 4. So there's our vertex, 4, 4. Now we're going to list our x-intercepts, which are the points right on the x-axis, which were 2, 0 and 6, 0, which are in our chart. So the x-intercepts were 2, 0 and 6, 0. And the y-intercept next was the point right on our y-line, which was right here, which is 0, negative 12. And lastly, we knew at the beginning that it was going to open down. because of the negative x squared. One more thing I could add here that I forgot to do was the reflection point that we found right here. We could put that point in our chart. It's not something that we list in our answers down here, but the coordinates of that point, the y value was -12, and the x value was 4 and 4 more, so 8, -12. So I'm going to put that in our chart. Putting this point in here helps us see the symmetry. We have our axis of symmetry with the vertex, the two x-intercepts, and then the y-intercept with the reflection point. And we have matching y values out here and matching y values with the zeros. So I do have one more problem for you to practice before you have to do homework. There's one more problem in your packet. Y equals -x squared minus 6x minus 8. So if you want to take time to practice that on your own without looking at my solution first, go ahead. Otherwise, I'm just going to post the solution and not really walk through the whole thing one part at a time. So here's the solution to example 2, which is your practice problem. I'm going to just go through it quickly up here. Our a value is -1 and b is -6. So you need to be careful. The formula is x equals -b over 2a. So we have negative from the formula. B itself is negative. So we have +6 on the top. 2a is -2 on the bottom. Divides out to -3. That number's in our chart. Now we take and substitute -3 into the equation. And this is where you need to be very careful right here. The equation has a negative on the x squared, which is out here. X that we're filling in is negative. So we have a negative on the inside and the outside. And when you evaluate this, -3 squared is 9, but this negative carries down in front. So we have -6 times -3, +18, and -8, which works out to be +1 right here. So we have a 1 in our chart. Next up is to find our x-intercepts, which are to set this equation here equal to 0. With the -x squared, I'm multiplying through by the -1, which changes all our signs on the right. Makes it easy to factor now with the +x squared. Plus. So the solutions are -4 and -2, which go in our chart right here as the x-intercepts. And right here is the finding the y-intercept point. We set x equal to 0. So you always have 0 in your chart as well. And we come up to the original up top here. So 0, 0 leaves us with -8. So here's the -8 and the -8 in the chart. So this fifth point here I wrote in after I did my graph. So coming over and looking at the graph, here's the dotted line for the axis of symmetry. This red point is the -6, -8 that I found after I graphed it to find the reflection of this y-intercept, which is 3 units away. So 3 units away over here. So at the end, make sure you answer these questions out here. Axis was x equals -3. Vertex is the high point in this case, -3, 1. X-intercepts, we have 2 of them, -2, 0, -4, 0, which were the points right here and here. And then the y-intercept was 0, -8, which is this point right here, and opens down because of that negative at the beginning, the -x squared.